Hello and welcome to another free code session. My name is Jason Bach and we're going to keep going bug hunting. So this is the one I'm going to work on in this episode, hopefully the only episode. And I did do some setup before this, or I already made the branch. I've already made a test that shows that this fails. It's an interesting one because what happens is this is an interface that if you look at the two different methods that are defined on it, and when you pass in object as T, what you end up are two methods that are exactly the same signature. They only differ by return type. But what's happening is if I go to the test code, I'm not picking that up correctly. So I end up creating two send methods that have exactly the same signature. Again, they differ by return, but that's not a different overload as far as C# is concerned. So what you end up having to do is, if I go to Sharp Lab here, you'll see that you have to implement one of them as explicit. So I have to pick up somewhere when I'm getting the methods. I need to be able to determine that they're exactly the same, but one of them, and it doesn't matter which one, you just have to pick one to say it needs to be explicitly implemented. Okay, now if you do string or anything else, then it works just fine because these two are different. So there is no issue with doing that. So it's interesting to note that this came up with that code generator test, and I was just passing in object because it was the simplest thing to pass in to generics unless I needed to do some specific mapping. And with this interface, by doing that, it exposed this bug. Again, this is a very corner case one. If you passed in, and in all likelihood, this came from, I think, mass transit. Is that yeah. Probably what you're doing is passing in a message type and you're not passing in object, and that's not what you want to mock in all likelihood. But we should still handle this case as esoteric as it is. Okay. So I have a breakpoint here on when we get mockable methods, because I'm guessing when we have their interface, somewhere in here is where I'm not capturing the types of things and determining if they should actually between themselves be the, it looks like this is with object methods. Yeah. The funny thing is with all these get mockable methods, properties, whatever, it's kind of there's a word I have for it, but I mean, you can see it gets rather large, and I feel like it's kind of brittle. I've been handling certain one-off cases, like the one I put up here in a comment with object methods, and that I can't conflict with those because that came up in a bug. So I'm guessing somewhere in here is where we are not determining that one of them needs to be an explicit implementation. Explicit interface implementation. That's what I meant to say. Okay, so let's run this test and get to that point to see what we can potentially do to handle this. Okay, so yes, we are an interface. So we look at the object symbol. We get all the object methods. It's probably 3 of them, right? Unless it's just an enumerable. So then we get all the methods on ourselves, which are ordinary and can be referenced by name. And there should just be 2 that we're going to find. One of them is this one, and then one will be the other. Okay. So we see that it can be seen. It is abstract. No, I'm sorry. That's just a flag. So if it couldn't be seen and it is abstract, then we have to handle inaccessible abstract. Oh, that's right. Yeah. If you have a, not protected, but a internal, and we can't see it, then we can't. But we basically, I think we then throw a diagnostic and say, we can't do this as a mock. So, okay. So now we look at the object methods and we try to find any that have a match. Now this is interesting. Okay, so we're saying, does the self method require an explicit? So we're trying to look at the object methods to say, do you have any? Or what we could do at this point, because this is just going over the methods that we have in this interface, or match on what you currently have. And then if you have something that just differs or isn't exact, then we're going to do an explicit. I think this might be, I was about to say, I think this might be an easy bug to fix, but I'm like, oh no. Don't get cocky. Do not get cocky, kid. Okay. So I think what we want to do here is say, or it's a vacation, but I forgot how to code. So you look at the object methods and you see if any match, or you look at the methods that you currently have and say any. Okay. And now we're going to do the same thing. So we're going to say basically this, which we could put that up in a, we could probably do that as a local method. Now, what are you complaining about? Method mockable result. Oh, result. Value. Yes. Okay, now here's the thing. By just doing this one thing, who knows what else I've broken? Yeah, I mean, that's how much of a house of cards this feels like at times. So I'll need to put in a comment here to say we need to look at the object methods and any previously found methods to see if we need to handle that, because otherwise this is going to be a big pain. And there needs to be at some point a rewrite of this. I feel like I'm kind of doing this sort of haphazardly in a way, and it feels like there should be a cleaner way to do this, but it is what it is right now. And one thing I was thinking about today, what might be an interesting video series or presentation, is how do overload methods work, or how does overloading work in C#? Like, you'd think that'd be a simple concept, but I was, as I woke up this morning and I was just kind of like sitting in bed, relaxing, I'm sitting there going, because this problem kind of sort of relates to overloaded methods. And how do you do overloaded methods? Because this starts getting into pretty much everything in C#, at least a lot of stuff. Like, you have to understand types, you have to understand inheritance, you have to understand what optional arguments are, and return types, and names, and all sorts of things, and order, and how this all works. And like with deconstruct methods, they're different because they are overloaded in a different way, purely by the number of parameters, and they have a certain structure. Yeah, I remember reading about Eiffel, a language, years and years and years and years ago, that I don't even know if there's any maintenance done on that language anymore. And I never actually programmed in it, but the concepts in the language, some of them were kind of interesting. And one of them was just with any kind of overloading, they said there is none. You just have to have different names for everything. And you can say, oh, that gets really painful. And that's true. It can get painful from that perspective, but it also makes a whole set of problems go away that you don't have to think about, because you have to have every method have a different name. So in any event, okay. So putting this in here, does that fix this? What this should do is make one of these explicitly implemented. So let's just see what it does from a generation standpoint. And of course, if this works here, we're going to have to run this on all the other tests. We're going to have to run this on the integration tests and run it on the code generation tests. There's a whole level of testing now, but that's good. It's good that we have all these tests in place. Okay, it failed as expected, but how did it fail? So we have here, now we have, it picked up an explicit, which is good. And one of these, I bet, yeah, now this one is now set as an I request. So that's now done that way. And then we should have that changed because it's going to give a different name. Yep. Same there. And then we come down here and now there should be an explicit. So what I'm going to do is just the regeneration. Okay. So what did I do? there. Okay, so give me a second. I'm going to regenerate this and get it into the state where it actually creates a hopefully passing test. Okay, we have success. It actually passes now. So this is okay. Now, next level of testing is let's actually come over to here and let's run all the tests in the test project and see what happens. That level passed. So we got all the tests passing there. Now I'm going to reload, and I should probably, if I go look at the integration test here, I have, now that I thought about this, I haven't been doing this as much as I should. But what I should do is maybe have a test here for that. So I'm going to shut down, start up again, and I'm going to make sure that I have a test in place for this using an integration test. So I'll get that in place after I shut down and restart Visual Studio. Well, that was quite the adventure. It works. And I now have tests that are in place, all the test runs. So the last thing I'm going to do is run all the code generation tests without including mass transit and then including it. I don't think I actually include it just yet. So let me make sure. If I go into code generation tests and I look at program, I think whoops, that's not the button I wanted to hit. Yeah, it's here. So we'll see what it does without it in, make sure it doesn't break anything, and then we'll bring it in and see if it fixes anything. But what was interesting with this, because it's such a kind of corner case, is one thing I realized, I didn't see this before, is when you do methods here, you can actually keep chaining that. And that's really not the intent of what I want to do. So this is just an unfortunate aspect of the fact that the methods is returning a method expectation, which I think derives from expectations. So you can still call methods here. And that was confusing me a little bit. So you just have to, by convention, only do this once. And this is actually where potentially not having this be, well, anyway, it's neither here nor there. It works. But that was confusing me because I'm like, the send on both of these were the same. This send now is the one that just gets a task. This send is the one that's task of object. Okay, so that all works. Figured that out. Here's the funny thing, though, is that when you try to put an explicit cast here to say, I want to do an explicit implementation call, it doesn't know or care what you're talking about. It will actually say it's a redundant cast. So and then if I don't put these qualifications here for the name of the argument, it will fail. You have to be specific in this case to say, in this case, I want to call values because that's actually the one that's going to return a result. This one just returns a task. So we need to pass in message here with these right values. And now it passes, it works. So this isn't so much of a consequence of rocks per se. It's just this one interface when you pass in an object type for T, things get kind of squirrely. And this is also, I'm getting more convinced that should be on my to-do list, is really dive deep on method overloading and what it means, because in some cases like here, there was no way to differentiate between the two other than stating the name of the argument. And this also now gets into versioning, which is if this would change and suddenly change it to be value, which is kind of odd that it's values, but if it was value, that would break me here. You can't change the name of that parameter. So lots of things when people say, oh, just add this feature to C#. How hard can this be? Well, in some cases, it can be extremely hard to make sure you didn't break anything. I mean, what I'm dealing with here is just probably a very small subset of what the C# language team has to deal with when they're putting in new features or fixing things that are currently there. So what I'm going to do now is I'll run the code generation tests and then without mass transit, and then I'll put it in. And we'll see what the results are. That takes time, so I'll run that and then I'll come back with the results. Okay, so Not quite there yet. There were some errors that came up, but they were kind of expected in that when we do a create, we're actually seeing 16 and now we see only 6, and all of these are just mapping errors. So mass transit always needs a lot of mapping things. So if I say here request settings, and I always do this request thing. Yeah, excuse me. I'm just going to have to go through these one by one and add the mappings. And then I'm going to run the program again with just this running so I don't try to do all of them again. So since this is kind of busy work, I'm going to put in the mappings. I'll run it again, and then we'll see what happens with the results. Okay, I may need to move this to another episode and finish it there because I'm not sure how to handle some of these issues now. What's interesting is that I think I'm going to end it by just finding out what the second thing is. What's interesting is that we do get 22 errors. So we actually get more errors now. One of them is very disconcerting because it's the error initially came from, this whole issue came from request send endpoint. And that's what we based on. But now we're getting iRequest client of object and saying explicit interface implementation matches more than one interface member. Which interface member is actually chosen is implementation dependent. Consider using a non-explicit. You know what, actually, hold on. That's the one we're working on here. Okay. And then, yeah, that's not a bug that we have considered before. I don't think we've ever seen something like that. So this may be similar, but we're going to have to look at that one. And then what are all the other errors? It doesn't seem to be able to, it gets this error that I'm thinking is actually part of this, that we get a line number here that isn't in the array. So hold on, I'm going to run this and see when it hits this and see what's actually happening. Okay, well, we're seeing a couple of other errors here. In fact, if we look at errors, that should be the 22. And was I able to do so? Like, how did I get all these errors before? I think it's because I was printing them out. So, okay, so what's the line number here? It's 252, and the number of mock code lines is 188. So that's interesting. Like mock code lines, create expectations of requests started. Is that what this is? Yeah, this can't be all of them. This is just one of them, right? Sorry, sometimes I don't remember what my code does. So we do a parallel, we get all the discover types, and then we say generate. Now what's interesting is that the generator compilation doesn't have any errors or diagnostics. Like that's okay. But then when we actually try to compile, the emit fails, because that's what we see up here. And so we see the 22 errors. So then we're starting to go through all that because we get the types and we get the code. Output compilation, syntax trees too. Well, that's like, I'm just confused at my own code and going, what did I actually do here? How many syntax trees? Yeah, there's 730. And that gives you like a lot of mock code, right? It gives you 10K, but that's just that one. So did it only do one? No, because it found 729. And that's what he said, it's like there's 730 syntax trees. A lot of these you can see are where you also get some of the usings from that stuff, but these are all those. If you say syntax trees here and then you do a to array, and that's just saying, I think, everything but the last, like, wouldn't this be just really, really big? Why is this request started? Why is that the name of this? I'm so confusing myself here. So yeah, that has all the different ones that we can actually create. Again, I haven't looked at this in a while, so I'm a little stumped as to what I actually did here. That's the output stream. And we get warnings and we get errors. But then we say mock code. What is mock code? Lazy syntax tree. Of course you're lazy. I don't know why you're lazy, but this should say to array. Right? I don't understand. If there are, and then we to array it, and I get where this is saying that the errors line, get line span, start position, and we say line, and we get line number, which is 252. But when we actually look at the number of, no, what are you, mock code lines is only 188, which doesn't make any sense. I mean, the amount of code that, I don't want to do live share. Oh my God, go away. All right. So we definitely have another bug. I mean, that is here. And I'm going to set up another one to say, okay, let's go look at this interface. Do I actually have that in the list here? Like if I look at the listing of things, nope, it's not something that's in here. We didn't need a mapping for it. It's just a request client. But for some reason, it's still being a pain in the butt. But it looked like most, if not all of those errors were the same. Well, not all of them. These are, because these are all in request client. Then there's this default value specified for these will have no effect because it applies to a member that is used, because I don't know what the heck that is. So I'm going to try to gather up. These all look like they're from iRequest. There's one for published topology. So I'm going to grab that one too. Okay, so I'm going to have to kind of pick and parcel this out and figure out like what this is doing. Why is it only seeming like it's getting not enough? and then, yeah, because the errors are from the result and the diagnostics, the result of the compilation. And the output compilation, all the trees, it should come from that. Some like, unless there is an issue with that potential split there. Like the split isn't actually happening on the correct line. I don't know. Anyway, I'm babbling right now. We've got more work to do, but that will happen in the next episode. Thank you all for watching. Leave comments and questions below. See you in the next episode.